So quick reminder, the difference between an aldehyde and a ketone. Where an aldehyde is always found on the end because you've got a hydrogen here and on a double bonded oxygen here, a ketone on the other hand is going to be found in the middle of your carbon chain. So these R's here can represent any amount of carbons in either direction. So unlike an aldehyde, you don't have to indicate what spot it's at because it's always going to be at the end, spot 1. Ketones, on the other hand, you do need to identify where they are because they could be anywhere within the carbon chain. So the ending for a ketone is going to be 1, O-N-E. Otherwise, all the rules remain the same. So in this particular case, it's propan 1. The reason why is because the only spot it could be is at spot 2. If it's on an end here, what is it going to be? It's going to be an aldehyde. One typo from your notes I'd like to change here. This should just be butanone, because the only spot the ketone could be is at spot 2. Now, if we had an example like this, where you have your double bonded oxygen there, this would be pentan 2-one. Why is that? Because the ketone group could be at spot 2 or it could be at spot 3. So if we look at this example right here, we want a number to give this the smallest number. So this is going to have our ketone spot at spot 2. So we got a 6 carbon chain, so it's a hexane 2-one, and we have a methyl spot at spot 3 and spot 3 again. So therefore, if we put all this together, hexane root, suffix of 2-one, and the prefix of 3,3-dimethyl. So therefore, it's 3,3-dimethyl hexane 2-one. So if we want to draw the structure for 5,5-dimethyl heptan 3-one, well, what do we need to know? Because it's a heptan, we know there's going to be 7 carbons. We know the carbonyl group is on spot 3, so it's going to be a ketone. And we need to have 2 methyls on C5. So when we put all those things together, we're going to end up with a structure like this. Yet again, the carbonyl group is on spot 3, the methyl groups are on spot 5. Now, with aldehydes and ketones, they tend to have strong odors. They tend to be polar compounds due to the carbon-oxygen bond here. There's no hydrogen bonding in these cases. It's simply due to the dipole-dipole interactions of right here. So as a result, they end up having lower boiling points. They also are able to be soluble in water. Yet again, the positive end of the hydrogen can interact with the negative end of the water, and this can produce a hydrogen bond.